Today we are going to solve a problem using Faraday's laws. Here is the question for you. How many hours would it take to produce 25 grams of metallic chromium by the electrolytic reduction of chromium 3 positive ions from a chromium salt solution when a current of 1.25 ampere is allowed to pass through the electrolytic cell? Let's see what we have first. You're given the mass of chromium deposited, which is 25 grams. You're given the current strength, which is 1.25 amperes. And we are supposed to determine the time taken for depositing 25 grams of chromium. And the time should be expressed in hours. Before we start, let's actually make a diagrammatic representation of the electrolytic cell. Here we have the electrolytic cell, we have a battery, and a meter showing a current of 1.25 amperes connected to the cathode, which is a negative electrode. The positive electrode is connected to the anode, and we have chromium ions in solution. So that's a circuit that is set up. Now we're going to look at the reaction that's going to take place at the cathode. Its reduction, Cr3 positive plus 3 moles of electron gives you 1 mole of chromium. Or in short, we can say every time 3 moles of electrons are flowing through the circuit, it actually deposits 1 mole of chromium. The reaction that is taking place at the cathode, as we already know, is reduction, and the metal is actually being deposited around the cathode. That's what's really happening. And that reaction, as you know, is called reduction. And in this case, 25 grams of chromium will be deposited at the cathode. Now, the equation above says if you have 3 moles of electrons flowing through the circuit, we get 1 mole of chromium. So how many moles is 25 grams of chromium? We will convert the 25 grams of chromium to moles, divide the mass of chromium by the molar mass, and it will give you 0.481 moles. So now that we have the number of moles of chromium, we also can calculate the number of moles of electrons that are flowing through the circuit. The equation tells you for every 1 mole of chromium, we will get 3 moles of electrons. So if you have 0.481 moles of chromium, we will need 3 times the moles of electrons, which is 3 times 0.481, which is equal to 1.44 moles. So that's the quantity, 1.44 moles of electrons that are required to deposit 25 grams or 0.481 moles of chromium. Now that we have the number of moles of electrons that are required, we can calculate the total charge. Now before we do that, we should also recall the relationship. 1 Faraday, which is the value is equals to 96,485 coulombs. 1 Faraday is the charge carried by 1 mole of electrons. The charge of a single electron is 1.6 into 10 to the power of negative 19 coulombs. And if you Avogadro's number, which is 6.022 into 10 to the power of 23, we will get 6,485. That's the charge carried by 1 mole of electrons. The equation that we are going to use is Q is equals to IT. Q represents the current strength in amperes. It's 1.25 amperes. And the time taken is in seconds. So once we have this equation, we can calculate the total charge. In order to calculate the time taken for the reaction to be complete or to deposit 25 grams of chromium, we will rearrange the equation T is equals to Q by I. So next we will calculate the total charge. 96,485 is a charge carried by 1 mole of electrons. 1.44 moles, therefore, multiply 1.44 moles by the charge, we should get the total charge flowing through the circuit. In this case, it's going to be 139,161.05 coulombs. That's a charge carried by 1.44 moles of electrons. Now the time taken is equal to, which is 139,161.05 or 139,161 divided by 1.25 amperes. 1.25 amperes is also equal to 1 coulombs per second. What it means is every second 0.25 coulombs of charge is flowing through the circuit when you have a current strength of 1.25 amperes. So actually, if you replace A with C by S, and if you divide the total charge by 1.25 second, the coulombs and coulombs cancel, and it will give you the time 111,328.84 seconds. So that's the total time taken for depositing 25 grams of chromium. Once you have taken in seconds, it's easy to convert it into hours, and that's what we're going to do next. $111,328.84 seconds times 1 minute by 60 seconds would convert the seconds into minutes, and multiply it by the next conversion factor, which is 1 hour by 60 minutes would convert it into hours. Common terms, seconds and seconds, minutes and minutes. What remains would be hours. Therefore, our calculation is right, and the final answer 30.92 hours are taken for completely depositing 25 grams of chromium. So we have used the equation Q is equals to IT, rearranged it to determine by dividing the total charge by the current strength, converted the time in seconds to hours, and the final answer we got was 30.92 hours. The time taken for 25 grams of chromium to be deposited is 30.92 hours. And that's how you calculate the amount of substance deposited at an electrode, in this case at the cathode. That's it for now. If you liked the video, please don't hesitate to rate, comment, and subscribe. Thank you and have a great day.